Hey, so still we are talking about performance, and I'm going to explain horizontal scaling in specific. And we would apply this horizontal scaling or scaling out for a backend component. For performance optimization, as I mentioned before, there are lots of ways, such as caching or maybe changing the protocol to communicate with a backend component, or making the backend faster by following the best practices, choosing the good algorithms to reduce the complexity of the app itself. But we assume that we have reached to a point that all of them are in a best situation, but still the workload is too much or too many requests are coming, and the computer that we have provisioned lots of resources can't handle those amount of requests. And this is when horizontal scaling emerges. For this video, I have considered as an example a simple like service. So we are going to make a backend component that does a bunch of logics based on the likes on a post. So imagine you are on Instagram and you click on the like button, that heart button, or every social media has that feature, and we want to optimize that. We want to make it fast, and the SLO, or the service level objective, or the target that we're pursuing, is to reach below 200 millisecond response time when the user clicks on the like button. And the backend component should handle 1000 requests per second. So the question is how? And hypothetically, we assume that our computer can only handle 100 requests per second at this speed. It means we have much more, or 10 times more resources. And provisioning or finding that memory or CPU maybe is too costly or not possible. And this is the situation that horizontal scaling can help us. But before that, I will explain this is an API that user can call, for instance, API/like/post ID, and by sending a request, maybe a post request to this URL and passing a post number, the backend component should respond and perform the action, the liking action, and should store the like of the user into some database or somewhere. But the backend component itself, I need to explain. What is a component, by the way? A component is basically a self-contained, independent, deployable, encapsulated part of the system. For example, in microservice architecture that we usually split the logic that are more relevant to each other into one service, that service can be considered as a component. And in fact, a component itself is made of building blocks. So building blocks are the more atomic entities in the system design, and we have lots of them. For example, a database can be a building block, or a caching system, or a load balancer, the one that we are going to explain in this video, or the app itself can be considered as a building block. And we have tons of them, and by combining them into a more independable unit of the system, we call it a component. For example, backend component can consist of the load balancer, a service, or the app itself, and maybe database and caching, and all of them. Another component might only consist of the app or a file storage building block, for example. But again, back to the main question: how do we do the horizontal scaling to achieve this goal? So the idea was to have multiple instances of the backend components. Let's call it a like service, or like service, like this. And I want to have multiple of them, and each one of these are components, independent components that I can just run on a computer, on a server. And users should be able to send some requests to each one of these. So there might be hundreds or thousands of users on the other side. Maybe user 1 is here, user 2, all the way to user n. And we need to distribute the traffic or the requests that are coming to the like service into these instances, because they can now handle, or each one of these can handle part of this. In our example, we consider, or hypothetically we said that each one of these can handle maybe 100 requests per second. So by having 3 of them, we can handle 300 requests per second under 200 milliseconds, for example. So how does it work? We need to somehow connect the user 1 into this one, user 2 maybe to this one, and user n to this one. But what about user 3 comes in? where should we send the request? Well, we can send and start over and send the user 3 to the service number 1 as well. And by the way, these 3 have identical application installed. But we cannot do it like this. We cannot say that from the user's perspective or from the place that user sets, send the request directly to like service instance number 1, number 2, or number 3. We need something else in between, and this is something that we call it load balancer. Basically, load balancer is a building block in the system design that distributes the traffic between different components in the system. So I would put a load balancer here, and sometimes you would see LB acronym as load balancer, but I would say write it down, load balancer, or the LB. And all the requests are going and should go to the load balancer itself. So the way it works is like I would connect, or I would introduce the load balancer as the entry point of my service to all the users, to all the consumers. So from now on, no one has any idea about like service instance 1, 2, 3, number n. They all know one entry point, which is load balancer. And the load balancer has some logics that would decide each request or which request should go to which one of these instances. And the way it works, or the logic that it decides, we call it the algorithm of the load balancer. There are a few algorithms or usual algorithms that load balancers have. For instance, round robin is one of them, or the simplest one. So basically the way it works is that user 1's request goes to server number 1, user 2 server number 2, user 3 number 3, and user 4 again starts over, goes to server number 1 again, and so on and so forth. Or another algorithm is that maybe some of these servers has more resources or is stronger, or maybe it has less connections. And then we can decide more requests to go to this one. For example, maybe 2 requests go to this service, which is stronger, and 1 goes to this one, to each one of these. So out of 4 requests, 2 of them would go to this one, to this stronger one. And that was another kind of load balancing algorithm that we can configure in the load balancer itself. And the load balancer itself, as I mentioned in the previous video, is simply a server that has the load balancer software installed and configured. Nginx is one of the favorite or popular load balancing software that you can use it. Nginx itself can also be used as web server, but you can also use it and utilize it as a load balancer as well. Okay, now it's time to do a demo and making some services, or launch some services and have a load balancer in between and try to distribute the traffic between those 2 services. 1, 2, 3. Okay, worth mentioning that load balancers can be installed within your infrastructure or on-premise infrastructures, or you can use managed load balancer services that some cloud providers provide. For instance, Amazon has their own load balancing system that you can utilize and do the configuration and connect it to your corresponding services. Okay, it's time for a demo and see how we can have multiple instances of the same application and distribute the traffic between those 2 instances using a load balancer. This is a repository that I'm going to use in this course, in this system design course. You can pull it from the GitHub. I would put the link in the description. And this is a turbo repo repository. So basically it is a monorepo repository. It can have multiple applications. For now, it has only one application, which is like service. This like service can be run and deployed independently, as I mentioned, as a backend component. And let's take a look into it. So basically, it has a route inside the app API like, and then post ID. You can see it supports different HTTP methods such as get, post, and delete. And the way you can access it, basically you would say localhost something, a port, then /API /like/post ID, which can be any text. And by calling this API, this get function would be called, and this will return the number of likes for this post ID that we have mentioned in the URL. And to add a like into the database, so basically you can call this method by calling the same URL, but this time with the post method, you can store the number of likes for that specific post ID and based on the current user. But let's continue. Yeah, you can see this like service and it has a Docker file. So if you want to build an image, a Docker file, the thing that we are going to do, by running two instances or multiple instances of this like service, we need a load balancer. For this purpose, I have created this infrastructure folder, and we have this horizontal scaling folder. And in this folder, I have created some infrastructure as code using Terraform to provision the resources or to declare the required resources. In this case, two instances of like service is going to be created and one instance of a load balancer that has Nginx installed with some configurations that are declared in this nginx.config.conf file. So let's take a look into this main.tf. If we go up, you can see it creates some networks for our Docker environment. Then it builds the like service image for us in the Docker, and then it runs the image into some containers called like service number 1. And also like service number 2 would be created here. And at the end, it would have this Nginx service as another Docker container that would be run on my computer. And then it will mount this nginx.config file into the Nginx container that is going to be run. But to run it, you can take a look into this README. Let's take a look. So I will do the steps one by one. Since I have installed the Docker and Terraform CLI on my computer, I would skip them, but let's take a look and let's continue. So it has the required commands to installing the Docker on different machines and also installing the Terraform. I have done these steps. I would skip. So in here, it says that let's go into the infrastructure folders, cd infrastructure, and then horizontal scaling. That is not mentioned, but I would go there, and then Terraform init. And on the current directory that we are in the horizontal scaling, by running the Terraform init, it would understand the files and interprets them. So next command would be Terraform plan. Let's run it. All good. And before continuing, we have to build the like service before creating the Docker image, because next command would create a Docker image from our application. So make sure you would create, you would build the project on your computer. Let me create another terminal like this. So in the root of the repository, I would run this command, pnpm install pnpm build like service. So it is built now. I don't need this anymore. So back to our Terraform terminal, I would do the Terraform apply. And I would type yes. Let's continue. It will create Nginx. Actually, it would do all the pulling from the Docker hub and create those containers for me. Also, it will build the Docker image for the like service, and it would run 2 instances of the like service into different ports that I have specified. And you can take a look here. If we go to the variables, you can see this is the image tag, and the port for the Nginx would be 3003. Like service number 1 would be run on 3001. 3002 would be like service number 2. Okay, all good. Now it's ready to be tested. If I go to my Docker, you can see the containers are running, like service 1 and 2 are running under these 2 ports. Also, load balancer under port 3003. So if I go to localhost 3003, let me open another one. So if I refresh, you would see that currently it is I'm opening the localhost 3003, which is the URL of the Nginx or the load balancer itself. And by sending this or by loading this URL, you can see that it loads, or it tries to get the data from one of those 2 instances. We don't know yet, but every time that I refresh, the request hopefully would be redirected to one of those instances. To test it, if I try to send a request to the load balancer, to a post request, so if I say curl-x localhost 3003 API live 1, enter, or actually I should specify the method, which is post. Now on one of these instances, the count, as you can see, is set as 1 for this post number 1. And let's refresh. So now you can see that this request currently returns 1. And if I refresh again, the count would be 0. And the reason is that I'm storing the number of counts in the instance itself. It's not stored in a database or in a shared place, which is another problem, which is but let's not concentrate on this. The thing, or the good thing that we see right now, is that the request, every time I refresh, my request would go to one of these instances, which is exactly what we need. So so Nginx, or our load balancer, is distributing the traffic very well. Now let's try something. What if I stop one of these instances? So if I go to the Docker and I would stop service number 1, let's do it. Now service number 2 is only there. Fortunately, load balancers, if they are configured properly, are smart enough that can understand if the instance is healthy and running, and they would decommission them if they are not available. They would not forward the request to those unhealthy instances anymore. In this case, the like service number 1 is out of work. All the traffic should be redirected to the healthy one. So if I try to refresh, you can see currently it's not done, or it's not decommissioned yet, because it takes a couple of seconds based on the configurations that I've made, or at least I think I have to make 3 requests to that service, to the load balancer, until it gets that it is unhealthy to decommission it. But let's try it again. Second time I see this loading happening, and maybe one more time. The unhealthy one got the request. Now if I refresh, yeah, from now on all the requests are going to the healthy one. So if to prove that, I would run the terminal again, and this time if I try to post again, okay, liking post number 2 and 3. Let's do a refresh. You would see on post number 2 and 3, still we are getting the count number 1. And if I refresh, I would get the same result. It means that all the requests are going to the healthy request. But also the good thing is that as soon as you start the service again, once again, so if I run the service again, load balancer would identify that and would start distributing the traffic into this newly created service once again. if I go back and try to refresh, you would see now the traffic is distributed between these two instances. So every time I get the count number 0, it's distributed to the newly generated one. Also, there's also good to mention that there's another endpoint, health endpoint. If you try it out, you can see that currently the request is forwarded to like service number 2 if I refresh, and now it's been forwarded to service number 1 once again, and it jumps from 1 to 2 every time I refresh. Okay, now let's go back to the Nginx config itself and see what is inside it and how it works. If I go to the infrastructure, horizontal scaling, and Nginx config file, you would see some settings or some configurations has been done here. For instance, I've defined this upstream like service backend, which will be used in the route, the main route in here. So I'm defining two services, or 2 servers actually here, like service 1 and 2, and it has some configs like max failure to 3, and if 3 requests to this server would fail, it would decommission or would stop forwarding the request to this service. Also, I've mentioned some other algorithms that you can decide. For example, if you want to have a weighted round robin, you can commit these 2 lines and uncommit this one instead. So in this case, I'm giving the server number 1 weight of 3 and the other weight of 1. So every 3 requests should go to the server number 1, and the 4th one should go to server number 2. Let's try it and see if it works. To reload the Nginx configuration, since this file is mounted into the container, what you need to do is mention it here also in the README file. At the end, you can see there is a section mentioned. If you change the Nginx file, you just need to run this command to connect to the shell and reload the Nginx itself. Let's do it, and it's reloaded. Now, if I go back to the browser, let's see if it works. I would refresh 3001, refresh again 3001, and now 3002. 1 1 1 2 1 1 1 2, and this is how it works. The weighted round robin algorithm works. It is ideal for when you want to distribute more traffic into one instance that you are sure it might have more resources and has more power or computation power. So that was it for this video. As you saw, we just created 2 instances by defining them into in our infrastructure as code or using Terraform. But it's good to know, as system designers, there are some services or some softwares that can do this kind of scaling for you, and they would expand your infrastructure on demand. So if the number of users, we assume maybe this tree can handle 300 users. What if we have 1,000, and then every time I have to manually do the job and launch few more instances? But the software that I just mentioned is called Kubernetes, for instance. So Kubernetes can be considered as another building block of the system design, and you just simply install and configure it, and you would say that in case of having more workload, or in this case more users coming in, just launch more instances, and if the number of users reduces, decommission them, and it would expand and shrink the infrastructure for you on demand. And we also call it auto scaling. And yeah, that was it. Thanks for watching, and if you have any questions, feel free to ask in the comments.